over 600,000 bridges in the United States which are in continuous use by our transportation network, but 25% of that inventory of bridges is either structurally deficient or functionally obsolete, which means that they're very expensive to maintain, and unfortunately structural failures can occur within those aging infrastructure systems. As a result, our project is looking at new types of sensors that can be installed on our bridges so that we can continuously monitor how they behave under their environmental conditions, how they behave under traffic loads, and how they deteriorate over long periods of time. In addition to collecting information about the behavior of our structures and the loads that are imposed on our structures, we also could take full advantage of wireless communications to give ourselves interaction with the loads that are imposed on the bridge. So we are looking at installing wireless sensor networks also on the vehicles that load these bridges, so that we can simultaneously collect data from the vehicles that are loading the bridges, as well as collecting data from the bridge themselves, so that we can better understand how bridges are deteriorating under normal operational loads.
The activity that I'm leading is the truck-bridge interaction. Actually, what we're doing here is we're figuring out exactly what loads the truck is putting into the bridge as it's driving across. And one of the complications is that you don't need to know just what load the truck has statically, but the truck doesn't ride completely smoothly over the bridge. So there are dynamic loads, and those will excite the bridge in different ways depending on how the truck hits the various bumps on the bridge. So we have a sensor network on the truck, and this sensor network talks to the sensor network on the bridge. And if you put it all together, you can see what the overall interaction is. And this is a critical part of the process, because if you don't know what's going into the bridge, it's very hard to see how important it is what the bridge response is. We have in excess of 20 sensors that are recording the dynamic loads on the truck, because we can't directly measure the force between the tires of the truck and the bridge surface. So we have to do some analysis to backtrack what those loads are. But we're using sophisticated instrumentation, and we know exactly where the truck is, and we can estimate what the loads are to a high degree of detail.
While the technology is highly innovative, we want to make sure it's synergistic with existing management methods such as visual inspections. So another thrust area of our project is looking at how can we combine quantitative sensor data with more qualitative type decision making that's done based on visual inspections.
This is a time-consuming process and ends up being subjective in many ways, because the exercise mainly involves inspectors going out into the field and using their engineering and professional judgment to rate different bridge components or elements. And these ratings together eventually lead to a combined rating for the bridge. And based on this rating, there are several decisions taken regarding the safety and structural usefulness of the bridge. By being able to interact with the bridge information model database while in the field, the inspectors will have access to previous inspections, notes made during previous inspections, any multimedia captured during previous inspections, and essentially the justification behind what a component or element of the bridge was rated during its previous inspections. And they can then correlate that information to what they observe in the field during that particular time and make a more informed judgment of what the actual condition of the bridge is at that point in time.